Okay, ladies and gentlemen, it's very nice to see you. It's a very great pleasure and honor to be chair on this section, main section. Um, exactly. I'm not chair, I'm moderator. My name is Alexander Marchenko. Now, our first uh, report uh, is called Enhancing Object Detection and Classification of High-Resolution Images using SAHI algorithm and modern neural networks. Andrei Yaroshenko, please.
Yes, I can't share my screen.
Oh, try again.
Yeah. Do you see my screen?
Yes.
Okay, so good morning, ladies and gentlemen. Today I want to present our work on enhancing object detection and classification in high-resolution images using SAHI algorithm and modern neural networks. The paper is brought to you by Alexey Bычков, Katarina Merkulova, Елизавета Жабska, and Andrei Yaroshenko. Let us first dive deeper into some fundamental theoretical aspects. Why we can't just use the detection model on an image and call it a day. Traditional inference with neural networks struggles to handle gigapixel images due to their enormous size and resolution. Neural networks are limited by the size of input tensors they handle. We need to resize the image, the big image, according to fit the neural network input sizes. This sacrifices critical details, particularly for small objects, leading to poor detection performance. On the other hand, the slicing-aided hyperinference, or just SAHI algorithm, is based on the concept of dividing an image into smaller, manageable chunks or patches upon which the detection model performs inference. Two critical parameters are used in this process: the patch size and the overlap ratio. These parameters play a key role in ensuring that the algorithm can process images of virtually any size while maintaining or even enhancing the level of detail compared to standard or plain inference methods. This approach not only increases flexibility but also improves the precision of object detection, particularly for small and densely packed objects within a scene. Once the image is divided into patches, the algorithm performs inference on each individual patch. The results from all patches are then aggregated into a unified dataset. However, this dataset frequently contains duplicate detections of the same object. This duplication occurs due to the overlapping regions between patches during the slicing process, making such overlaps unavoidable. To address this issue, post-processing is required to eliminate these duplicate detections. This is accomplished through the application of non-maxima suppression or NMS algorithms. NMS ensures that only the most confident detection of each object is retained, effectively resolving overlaps and enhancing the clarity and accuracy of the final detection results. All studied NMS algorithms rely on the key metric called intersection over union. It measures the overlap between bounding boxes. If the intersection over union exceeds a threshold, for example, 50%, the boxes are considered to represent the same object and are merged. Non-maxima suppression removes redundant bounding boxes, keeping only the most confident detections. This is essential because there is overlapping between patches. It just sorts boxes by confidence scores. A confidence score is a metric we get from detection model for each detection. Then it selects the highest score box compares its intersection of a union with the remaining boxes, and suppresses boxes with where IOU is above the threshold, and then it repeats over all the boxes. In our experiments, we evaluated the SAHI algorithm combined with 5 object detection models, focusing on 2 key variables, patch size and overlap ratio. Patch size, we tested 256, from as small as 256 by 256 pixels to as big as 1024 by 1024. Smaller patches are great for detecting small objects with fine detail, but it requires some significantly more computation. On the other hand, larger patches reduce processing time, but it might miss the smaller objects. The overlap ratio, we tested values from 0.25 or 25% and 50%. Higher overlap ratio prevents objects from being split between patches, but increases computational overhead. The object detection models, you can see them on this slide. During our evaluation, we evaluated 3 key metrics to assess performance. The execution time, that measures computational speed. It's crucial for practical applications where faster processing is essential. Error percentage. A lower error percentage indicates better accuracy and efficiency. It's a composite metric that balances both accuracy and speed. Higher value means better overall performance. All formulas are on the slide. For one of our studies, we selected this massive beach panorama. The image size is 0.122 gigapixels, which takes about 351 megabytes in RAM. It's stored in the PNG format. There are key observations. We tried to infer the image using the detection models, and without using the SAHI algorithm, none of the neural networks detected any objects in the image. With SAHI implemented, we tested multiple tile sizes and evaluated overlap ratios of 25 and 50%. The heat map on the left illustrates the detection results for different object classes when using a 512 by 512 patch with 25% overlap ratio. Each row represents a different combination of detection model and post-processing algorithm. The most frequently detected object, as expected, is person. However, notice the dramatic increase in detections when no non-maximum suppression is applied. It's shown by the underscore rows, which leads to inflated and redundant numbers. On the right, we see a graph summarizing results across experiments. The ground truth indicates approximately 1,100 people on the image, and the models are generally underperform without sufficient overlap or with larger patches. But their accuracy improves as we refine patch sizes and overlap ratios. These visualizations highlight the importance of proper post-processing and configuration for achieving reliable results. Let's compare the results with and without non-maximum suppression. On the left, non-maximum suppression is applied. The duplicate bounding boxes are suppressed, leaving only the most confident detections. And on the right, it's not applied. It's very obvious why we need post-processing when we use a slicing algorithm. This table summarizes the results of our experiments, evaluating the error percentage, execution time, and efficiency for various configurations. We tested all 5 detection models across different patch sizes and overlap ratios. The key takeaway is the trade-off between accuracy and computational performance. Smaller patches with higher overlap ratios, while more accurate, significantly increase execution time. Larger patches or lower overlaps reduce processing time, but at the cost of higher error percentages. Interestingly, Torch Vision consistently performed well in terms of accuracy, achieving low error percentages, and especially with smaller patches. However, this came with a noticeable increase in execution time, impacting efficiency. This analysis provides a clear comparison of configurations, highlighting the importance of balancing computational demands with detection accuracy to optimize performance. So we can clearly see that YOLO v5 and YOLO v8 showed similar performance overall, but YOLO v8 consistently outperformed YOLO v5 by a small margin. YOLO X stood out by detecting more objects overall, particularly rare classes, making it a strong choice for diverse object detection tasks. For torch vision, using patch size of 256 by 256 achieved the lowest error rate. This configuration, however, required extensive processing time, reducing its efficiency. And RetinaNet had the lowest detection count among all networks, highlighting its limitations for this task. For more detailed results and additional experiments, I encourage you to refer to the full paper. It provides deeper insights into the strengths and trade-offs of each approach, which are beyond the scope of this presentation. To conclude, our study introduced a novel framework for object detection in high-resolution images using the SAHI algorithm with advanced neural networks like YOLO V8 or YOLO X. We addressed the challenge of detecting small objects by dividing images into detailed patches, improving precision and recall. Notably, RetinaNet's results emphasize the ongoing challenge of class imbalance, especially for rare objects. Looking ahead, we see several future directions. Optimizing patching strategies to improve efficiency and accuracy further, and exploring advanced architectures, including incorporated attention mechanisms and transformer models to push the boundaries of detection performance. Ultimately, this study provides a robust and efficient framework for object detection in high-resolution images, paving the way for accurate and reliable systems across a wide range of applications. I thank you for your attention.
Thank you very much. Please, dear colleagues, please, questions. Is there any questions?
I have one question. Would it be possible to run these algorithms on microcomputers like Raspberry Pi, for example?
I think if you optimize the detection model to run on Raspberry Pi, and if you can provide the storage for the device, you can do it on the Raspberry Pi. Because this framework just needs these smaller patches and to compute to perform inference on all of them, and then you can do virtually you can process virtually any image size on any platform, and yes, it will work on microcomputers.
Okay, thank you.
Any other questions?
Have you done any your own model to detect objects?
No, it's
Just
outside of the
retrained
scope
model.
of this paper. Yeah.
Oh, thank you.
Understand. Any other questions, colleagues? No? So thank you very much for your report.
Thank you.
The next report, it will be Maxim Огурцов and development of relative positioning algorithms for agricultural drone swarms in GPS-challenged environments. So please.
Ladies and gentlemen, first of all, sorry, I have a bad internet connection, so may not hear everything, and I will turn off my camera to hopefully it will make my sound better for you.
Okay.
Our report is development. Suppose you can see my screen.
Yes, we see.
Great. Development of relative positioning algorithms for agricultural drone swarms in GPS-challenged environments. In recent years, agricultural drones have significantly increased use for tasks such as field irrigation, pest detection, and crop health monitoring. To enhance the efficiency and speed of operations over large agricultural areas, drone swarms are increasingly being used. However, in remote regions where GPS signals may be inaccurate and unavailable, the need arises for effective methods to determine the precise relative positions of drones within a swarm to prevent collisions and ensure high precision task execution. And proposed solutions that are usually used nowadays typically rely on expensive networks of fixed stations, such as anchors, with verified positions. And this is not applicable for all of possible tasks. So the purpose of this work is to develop relative positioning algorithms for agricultural drone swarms in GPS-challenged environments. These algorithms should enable the determination of the relative position of drones and the overall configuration of the swarm, even in the complete absence of GPS signals or with such signals available only to the swarm operator. Algorithms should work even in case of long distances between drones. Over past years, numerous scientific studies and practical implementations have explored the use of radio modules for positioning small mobile robotic systems such as wheeled robots, quadcopters, and so on. I will not stop to save some time on the standard practices. So algorithm for calculating the distance from a drone to the position of another drone and the viewing angle from the drone to the zone. To determine actually the directional angle of each drone relative to another, measuring only the distance between them is insufficient because you will know, for example, that second drone is 100 meters from you, but you will not know is it in front of you or behind you without the directional antenna. Consequently, the deployment of two drones is required to measure the distance to a third drone and thereby facilitating the calculation of their respective angular positions. So we have drones A and B, and they want to know position of drone T. We know distances with some measurement error from A to T and from B to T. So T actually is not located from the point of view of drones A and B at a specific point, but rather in a certain zone formed by the intersection of these circles. Distance between drones A and B determined using the same methods as distance to drone B, and relative positions can be defined using data from cameras on these drones. So here is some trigonometry. I will not stop on all the details and encourage you to read the full article to see the mathematical apparatus use it to find the relationships between all the values. It's actually some calculations which are not very resource demanding, so algorithms working pretty fast. So I will skip all the formulas. Here's the illustration of derivation of the formulas for the distances h1 and h2 to the drones, and we coming to find actually the angles, the main point, and with the intersection point of the two circles and use of Pythagorean theorem, we are able to determine the relative positions of the swarm elements with high precision. Two practical tests and more interesting. The derived formulas were validated experimentally by creating several test datasets for various relative positions of the drones and different distances between them. The obtained results confirmed the probability of the created mathematical model, allowing the determination of the relative position of drones in swarm relative to each other. As a result of this study, the algorithm for determining the relative position of swarm elements in the absence of GPS signals and the corresponding mathematical apparatus was developed. It takes into account possible inaccuracy of distance measurement. Various configurations of potential relative position within swarm elements, their influence on the accuracy of relative position determination, and solutions to issues arising from suboptimal initial configurations were analyzed. The results were validated through practical computational models. The obtained results confirmed the operability of the created mathematical model, giving measurement error of 1% or less. Future research will focus on the practical application and empirical evaluation of these findings within operational drone swarms, and special attention will be, of course, directed towards enhancing the relative position accuracy of closely spaced drones using visual techniques, particularly by integrating advanced computer vision algorithms. Thank you for your attention, and if you have any questions, please ask.
Thank you very much, dear colleagues. Please, questions? Yes.
Yeah, thank you very much for this great speech. I would like to ask, have you carried out any practical experiments within the real environment? And if so, could you please elaborate a bit more on the environment in which you probably tested your contribution? Thank you.
Of course, we run several experiments with small drones, three to be precise, because we have three, without flying for now on the field. So we're moving them and measuring distances, testing our algorithms, and actual results were the same as predicted.
Okay, thank you very much. Got it.
Another questions? No questions. Thank you very much. So we go on.
Thank you.
The next will be Savchenko Mikhaila and optimal size reduction methodology for YOLO-based underwater object detectors based on knowledge distillation.
Yeah.
Please.
Hello, colleagues. Could you please tell me if you can see my screen?
Yes. Receive.
Okay, thank you. So we, with my professor Victor Sineglazov, we are presenting the paper called Optimal Size Reduction Methodology for YOLO-based underwater object detectors based on knowledge distillation. So first of all, I would like to start with the concept of autonomous underwater vehicles, which are unmanned devices widely used in water resources research. The main strengths include that they allow to work completely autonomously, and they don't require any human assistance or presence on site. They can work on considerable depth and distances which are often unreachable for us human, and they can obviously help us to obtain the necessary visual data and information from various sensors, for example side scan sonars and other hydroacoustic sensors, cost efficiently and very quickly. So the application of AUVs includes the variety of fields, which are biology for exploring biodiversity. Archaeology can take advantage of looking for underwater historical objects. Oil and gas field explores ocean floors to find optimal routes with AUVs. Ecology uses it for pollution monitoring, and military and rescue services using them for their own very important tasks. But first of all, AUVs are nothing if they don't carry an intellectual system on board. So the main problem is to create an intellectual system which is based on deep learning, which can enable these AUVs with object detection capabilities and allow them to work in even more scenarios. So first of all, the proposed object detection network should be accurate enough to work with images taken in underwater environments, which are often characterized with various visibility issues, for example, low contrast and small size and dense package of these underwater objects. And on this slide, you can see the example of such images taken in a real underwater environment. And another important point is that apart from being accurate, this network should be small and efficient enough to be deployed on edge hardware, which is often NVIDIA Jetson or Raspberry Pi, and it should be carried by AUV as an external module, but this external module has limited performance and battery life. And another important aspect is that this module should be cheap enough so it's more accessible. So here's the main purpose of this study. The main purpose is to create such an system optimal size reduction methodology for underwater object detectors, which is based on YOLO network architecture, which is well known and it works pretty well with targets of this type. So the resulting methodology should allow to develop an object detection neural network, which will work correctly with the images I have mentioned above, and the deploying of this neural network should be accessible on low-powered and low compute hardware, which can be installed on AUV as an external module. Again, this is a Raspberry Pi or NVIDIA Jetson. And here is the sample of the desired output we should get from this proposed network. The mathematical problem statement includes building two neural networks, which are teacher and student networks. Both networks can accept input samples, which are the RGB images from the underwater image dataset. And they also carry the Y, and Y here is the vector of ground truth bounding boxes, and bounding boxes basically the box surrounding the object within the image, and it also has the information about class labels for each object within this image. The teacher and student models have its own weights, and it should be trained in an optimal way to carry the transformation from the RGB image to the vector with this bounding box coordinates and class labels. The dataset we have used in this study is underwater target detection algorithm challenge from 2020 competition. It includes over 5,000 images in 4 classes, which are small and often unstructured and hard to discern. The classes in this dataset are also imbalanced, with a lot of objects in the majority class and a smaller number of objects 4 times smaller in minority class. And we have also used a validation dataset which has over 1,000 images. And here is the example of the validation image. So our proposed approach, which we have developed in this paper, includes developing a knowledge distillation algorithm, which will enable transferring knowledge from a teacher model, which is a larger capacity model, and a student model, which is the smaller model, which can be directly deployed on an edge device like Raspberry Pi. And those models are based on YOLO architecture. Here in this slide, we can see the overall structure of the proposed network, which includes the backbone part, which can actually extract features from the RGB image and produce feature maps of various sizes, which are then processed by NEC module. NEC module carries upsampling and aggregates the features of different sizes into one feature pyramid. And then the parts of this feature pyramid are discerned by a network head, which has multiple, it's called decoupled heads, which handle regression and classification tasks. And another task in our proposed approach is to build a lightweight student model, which is applicable to be deployed on this resource-restrained device, which will utilize computationally effective convolutional layers to reach the desired size and parameter count. So here is our knowledge distillation algorithm. We have developed this to enable knowledge transfer from larger teacher model into lightweight student. And to do this, we have modified the regression and classification components of total loss function to include distillation loss and include additional weighting coefficient to avoid learning collapse and avoid another scenario when the student model is totally mimicking teacher outputs and doesn't produce any meaningful results. Additionally, we have added a temperature coefficient and have employed a linear decay strategy to control the softening of logits for classification component to regulate the amount of knowledge a student network can get from teacher on each stage of training, which can help with training stability. Here is the loss function of this model. So loss function can be divided into regression and classification loss, which are CIU and VFL losses, a very vocal loss function. We have added corresponding distillation coefficients to each of these loss functions and scale it by, for a classification function, we have scaled it by temperature to control the stability of training and encourage exploration in earlier stages of training and focus more on confident predictions in the later stages of the training process. Another important task was to build a lightweight student model topology, which can be directly deployed on a smaller resource-constrained device. And to ensure this, we have modified the feature extraction part of a YOLO network, which is called backbone, to reduce the number of expensive convolutional operations, as this module in original YOLO network is primarily composed of 3x3 convolutions, which are computationally inefficient, and we have replaced it with the components we have derived from mobile network architectures such as GhostNet and FasterNet. So let's dive deeper into these two networks. The core idea which is used behind the design of GhostNet is to reduce the number of these 3x3 convolutions in favor of the operations they call cheap operations. So the main task is to generate more feature maps using the intrinsic to obtain intrinsic feature maps by using less computational operations, by using the series of linear operations or pointwise convolutions. We generate more feature maps and then aggregate it to get the resultant feature map. Here is the structure of this process. Another approach we have used in our backbone network is the FasterNet approach to convolution, which applies a slightly different approach. It's called partial convolution, and in this case, the convolutional operation is only applied on a part of input channels to extract spatial features, and it leaves the remaining channels untouched. And then it is followed by the series of pointwise convolutional operations to reuse the information from all the channels we have missed in the previous stage. This is the approach we have used in this modification. The metrics we have used in this experiment are pretty much standard, which are MAP at different IAU levels. IAU is intersection over union. And we have also measured parameters count and flops, which are a number of floating point operations per second for this network, and the size, as this one is important to deploy it on a smaller device. We have also tested this model on NVIDIA Jetson, which is a computationally restrained edge device. So here are results of our experiments. We have measured the accuracy and the parameter counts of different standard well-known networks, such as unmodified YOLO and RetinaNet and FCOS network. And we have also measured the results for our distilled network, which turned out to be as efficient as a larger YOLO V8M network, but it uses a lot less parameters and is actually closer in terms of parameter count and size to the smallest model from YOLO family. Here are some visual examples of the proposed model. So as we can see on the left side are the ground truth labels, and the right side depicts the deductions made by our proposed models. The conclusions are that our paper proposed a novel methodology to reduce the size of YOLO-based underwater object detectors with the usage of knowledge distillation algorithm and temperature decay strategy to control training, which has allowed us to efficiently train a lightweight student model and deploy it on an edge device. Additionally, we have built two lightweight YOLO topologies, which are based on GhostNet and FasterNet approaches to convolutional operations, and these two models are suitable to be used as a student model in knowledge distillation tasks. So our proposed lightweight model are 40% more efficient in size and memory consumption, but in terms of accuracy, due to the knowledge distillation process we have used, it's actually closer to a larger model in terms of accuracy. And the applications of this methodology include training and object detection network to be used in integrated autonomous underwater vehicle hardware. Yeah, thank you.
Thank you very much, dear colleagues. Questions, please. Yes, Pablo.
Yeah, thank you very much. And thank you, Mikhailo, for this great presentation. I would like to kindly ask two questions. First of all, I really wonder, why did you apply the distillation process specifically to the small YOLO model, taking into account that both nano and small YOLO models are designed for such tasks, and they are basically small and plus minus precision and accurate enough for such tasks. Why did you try to apply distillation to extremely large YOLO models, for example, YOLO medium, or at least YOLO, or even YOLO large models?
We have applied distillation to we have taken the larger model as a teacher model and taken our own smaller model with a custom backbone, which used GhostNet and FasterNet backbones as a student model. So actually, our network is closer to S and N models in terms of size, and it actually takes this features from the larger models in terms of knowledge distillation algorithm. And why not just? I understand your question. You actually want to ask why not straightforwardly use the smallest model in YOLO family. I would like to use it, but I think that the difference between YOLO V8N and YOLO V8S in terms of accuracy is actually quite large. So the goal was to make the model which would have the size of N and actually be closer in terms of accuracy to the S model, which is not so small, actually.
Okay, I understood. But please think about applying distillation to larger models. I think it can be a great opportunity for further research.
Yeah, I agree. Yeah, but it's a training with a knowledge distillation algorithm actually takes a lot of time. So we didn't have that much time before the conference to test every model.
Fairly understandable. And my second question will be again about YOLO. As far as everybody knows, YOLO usually struggles with small object detection. Have you addressed this issue within the distillation? Because while we distilling the knowledge, the opportunity that small objects will be missed is higher when we use typical, let's say, original architecture. Did you think about that?
I thought about that, and actually we had the previous research which is focused at detecting smaller object and overlapping object. And actually I have used some parts of that research in this one. And to be more specific, we are using a different upsampling process with an operator which is called CARAFE, which handles upsampling process not by applying the interpolation to a smaller feature map, but it actually serves more like a attention module, and it focuses on region of interest in this feature map, and actually uses this information during upsampling. So if you want to know more about that one, you can check my previous papers, which have this algorithm.
All right. Thank you very much. I'm fully satisfied.
It's tailored for smaller models. But actually, when we have developed that one, I had another question from the chairs, and they said, why you are so sure that every underwater data set has a lot of small objects, and that one is also true. So if we optimize too much to one data set, this model actually its generalization capabilities are actually lost a little bit. So here, if it's applied to a real world task, I agree with you, we can optimize that task. But if we are developing it as a methodology, it's actually better to develop the algorithm which works well with different tasks.
Yeah, fair enough. Thank you very much.
Thank you for
Thank
questions.
you. Thank you. Any other questions? No?
I have a question, maybe the general question. What happens if you have a need to recognize an object which is not observed in your training set? For example, some new object which could be potentially put, which could be invented somewhere. Have you a solution for this? Because you have a very specific environment.
Yeah, currently it's optimized for biodiversity monitoring, but if we have the data set which includes different objects, we can use the fine-tuning procedure, and actually we can reuse the weights we had from our previous models and retrain on another data set. Or alternatively, you can use the knowledge transfer and freeze the later layers of our neural network and retrain on a newer data set which has another objects. That's the potential solution for this one.
Thank you.
Thank you very much. The next it will be Mykola Sajok. Toxicity detection in Ukrainian language texts in the text attributor system.
I hope you see my slides.
No, not yet.
And
not
not yet. Sorry.
Try again. Please. Oh, yes. It appears. Yes. Okay. We see.
So this presentation involved several co-authors from a couple of organizations, from research collectives. And we tried to develop toxicity detection mainly for Ukrainian texts, trying to cover both a computer-aided and machine for totally automated method to explore toxicity and some other related to this problematic questions like sentiment analysis, tonality analysis, and other text attribution issues. It's highly crucial for contemporary situation in Ukraine and in the world. And in a peaceful time, it could be also applied to improve text content, especially for media, for publics like chat, like internet, social network, and so on. The rule-based approach is built on lexicons, on several lexicographic lists, which are based on three sources. Two of these sources are continuously developed in the Cathedra of Computational Linguistics. Several tools are used to build this corpora, and the third source, it's a dictionary which was developed in frame of the diploma work by a master student. So the first lexicographic list is the Dictionary of Emotions. It covers 5,000 lexemes, which verbalize negative facts, emotions, fear, oppressions, shame, and so on. The second list is a hate speech dictionary. It covers 3,000 of lexemes verbalizing aggressive communication, like harassment, obscenities, bullying, trolling, and next slide shows you even more detailed categorization for this item. It's categorized so details like negative naming for people by nationality, by age, by gender, and so on. It's great for experts anyway. And the third lexicographical list is a dictionary of toxic compounds. More than 1,000 stable phrases are classified by 26 semantic features. And here we work with a larger context, not only with just words, and this allows to determine more proper segments of texts. Finally, we have a computer-aided system implemented in the text attributor web interface, where the user can upload his text. We don't control if it's taken from a media, from any social network. It could be actually any text. This is accessible by this link or by this QR code. Anyone can test it. So how looks this rule-based toxicity detection model? The result is such information that is valuable for an expert and allows him to determine is it proper text for toxicity analysis or it's completely neutral. So inside the text, the expert can look through the spotted words, phrases, and to be more convinced in his choice. Here is a smaller example where we can see that it contains five emotions and another kind of toxicity terms like vulgarism and sexism. So next block of presentation is devoted to machine learning methods. We try to investigate classical methods, deep learning, and large language models. Actually, we have some limitations on computational resources, so it is quite convincing to try less computationally huge algorithms and approaches. So we experimented on test and training sets, which are actually quite scarce. And in the beginning, we had only less than 1,000 of labeled analyzed texts. And further, we could train on dataset B, which contains much more items. So we applied the classical algorithms and as well as deep learning algorithms, and that were trained by a training set. And prompting for LLMs, it's just actually like zero shot. Only one prompt was used, quite simple to test the texts on toxicity, and this model of LLM is not so huge. It could be placed in 2024 RAM GPU. So this is the example how we can test on web this approach. Actually, here is implemented the better method, which is actually machine learning based, which is deep learning based method. And finally, we try to compare the relationship between rule-based and machine learning techniques results. Please did it already with customers' texts. More than 500,000 texts were collected from users during several months. Actually, these are only related texts. It's not some like long novels or whatever. So we can see that all these texts have some not so bad slope for correlation line, and when we when we consider only those texts where both where at least one system is aware, we can see that relationship is more distinctive. So in future research, we hope we can merge in some hybrid system both rule-based and machine learning approaches. Besides this, we of course develop corpora for text and some user-friendly issues in text attributor will be also improved. This is actually what I planned to talk. If you have any questions, please.
Thank you very much. Questions?
Yes, may I ask a question?
Yes.
Please.
Yes. Yes.
Alexey Yalovsky, National University of Kyiv-Mogil Academy, Faculty of Informatics. Yes, thank you for the very interesting talk. But well, using toxic lexics is a very primitive way of information influence. Yes, it works for many people, but it's very primitive and it is rather easy to detect such influence automatically. But there can be another way of information manipulations, which is related to very polite and maybe very positive texts, but are aimed at the same goal, to manipulate and should be considered to be very toxical. Did you try to recognize such patterns of such basically apparently positive texts?
Yeah, you have reason. Here we should analyze a larger context, and even a list of phrases is not sufficient in the situation you describe. On my opinion, core deep learning techniques is the only way to model correctly such situations. And anyway, this computer-aided techniques which use rule-based methods, it's not a limitation. The main goal of these resources is to collect huge corpora that we can train our systems with more sophisticated models. So thank you for your question. I hope I replied.
Thank you. Another question. Oh, please, hello.
Yeah, thank you very much for your presentation. And in addition to the previous question, I would like to ask, did you address the trade-off between false positives when flagging non-toxic content as toxic and false negative failing to detect toxic content, particularly in sensitive contexts such as online discussions? Because while detecting toxic content, false positive and false negative can be a real trick in here. So did you detect this issue?
Yeah, we addressed this issue. We can tune the parameters to achieve more sensitivity or more accuracy for the results. And you also touched the problem of learner text with discussions where people can express different opinions, and one may express a neutral way and some other intoxical way. It's rather related to next our stage of research, related to chunking and so on.
Yeah, that's a really tricky question because usually online people can behave differently while other can make fun, just a simple fun. Simultaneously, the other people can consider such behavior as a toxicity, while it is not by the impression of a first person. So, real difficult task, and I wish you good luck. Thank you.
Thank you.
Thank you very much. Another questions, please? No questions. Okay, thank you very much. Next. Next, it will be Zalutska Olga.
Yes.
Modeling of media influence on personal information security. Please.
I guess you read the wrong title.
No, wrong title. Oh, excuse me. I'm too fast. Method for detecting propaganda object using deep learning neural network models with visual analytic. I'm sorry.
Oh, it's okay. Thank you so much. So good afternoon, dear colleagues. My name is Olga Zabudska, and today I'm pleased to present you the work on behalf of all our authors on the topic Method for Detecting Propaganda Objects using Deep Learning Neural Network Models with Visual Analytics. The main purpose of propaganda is to manipulate the beliefs, attitudes, and behaviors of the target audience to promote a particular product, idea, or political agenda. Propaganda is often used in advertising, political campaigns, and public relations to shape public opinion and persuade people to support a particular cause or point of view. Propaganda can be used to create a positive association with a product or idea, to create sense of urgency or fear, to appeal to emotions, to create a sense of belonging or conformity, or to attack or discredit competing products or ideas. And the ultimate goal of propaganda is to influence people's decision-making and behavior in a particular direction. This approach uniquely combines detecting propaganda targets with correlating these targets to specific techniques using numerical values. It leverages 17 pre-trained neural network models based on the transformer architecture, enabling the identification of 17 core propaganda techniques. Here you can see the scheme of the method, which includes next stages. First of all, the first one is building set of propaganda objects by named entity recognition using standard network. Then it's text preprocessing and expansion of propaganda objects at expense of word representations using fast text model. Then the step of building context windows and associations of CW by PO is going. Then next step is detecting level of propaganda techniques used in CW by trained neural network models. And the last one is building set of important relations between techniques and the objects for this text. For example, at shown picture, the first step is to search for named entities. Two named entities are found in this text. These are Libya and Ukraine, both of them are locations. The set of nairs found must be further expanded by selecting semantically close objects. After passing the NER stage, the set of objects will be completed. And for this example, it will become Libya, these are conflict, and for Ukraine, these are country and authorities. The next stage is the construction of context windows for the found objects. You can look at the picture and find these windows at the big blue rectangle. The last step is to search for techniques in context windows. The assessment of the presence of the technique is carried out by evaluating the context window with a neural network trained to identify the techniques expressed in the text. For this example, For Livia entity, its appeal to field prejudice techniques was rated at 0.85, exaggeration technique was rated at 0.77, and loaded language technique was rated at 0.64. At the same time, for Ukraine entity, appeal to field prejudice was rated at 0.62, exaggeration was rated at 0.79, and loaded language was rated at 0.70. And taking into account the content of this text, the techniques are almost evenly distributed across the context windows. However, for the first context window, loaded language technique is less highlighted, and the appeal to field prejudice technique is more pronounced compared to the second content window. The developed web application uses 17 pre-trained neural network transform models resulting from our previous scientific research, Stanza neural network library for named entity recognition, Flask framework for building web application, and fast text pre-trained model, which is retrained on propaganda text. The created software has the functionality to determine the use techniques by text, also identify objects of propaganda, and analyze the affiliation of the detected objects to the used techniques. Here you can see obtained results of the accuracy of propaganda techniques detection by neural network models. And as can be seen from next pictures, not only the objects of propaganda and the use techniques were detected, but also the affiliation of found objects to the use technique was determined. Shown images presents the analysis of the text by a specialist on the Strategic Communication Center website for the presence of propaganda in text, and the results of analysis using the developed method in the application. So as the result of the study of the effectiveness of the developed method, it was found that the method for detecting propaganda objects allows obtaining results that are fully correlated with the results obtained by experts. And at the same time, due to the consideration of propaganda as a holistic model and the use of visual analytics of the obtained results, it was possible to achieve a comprehensive analysis of the relation between techniques and objects of propaganda, as well as to provide generalization for objects of propaganda and their alternative mentions in text. So a method was developed to identify who and what propaganda techniques targets within text, addressing issues like the lack of comprehensive analysis of technique-object relations and alternative object mentions. The method uses Stanza library for NER and fast text for object expansion, allowing a more extensive list of propaganda targets and providing correlation assessments between objects and techniques. The approach involves stages like named entity recognition, text preprocessing, context window building, and neural network models to assess propaganda levels and the relation between techniques and objects, resulting in a semantic model of propaganda for each text. Also, a custom software implementation verified the method effectiveness by comparing results with expert analysis, showing strong correlation. Also, plans include automating result comparison with expert analysis and dynamically determining minimum threshold values to focus on significant propaganda features while reducing noise in texts. That's all. Thank you so much for your attention.
Thank you. Thank you very much. Please, dear colleagues, question, please.
Well, may I
Nicole?
ask a question?
Nicole?
Yeah, short question. The presenter told that they used the Stanza library. From my experience, a spatial library gives better results for named entity recognitions. Did you try it?
Of course, we tried this library in our previous researches, but we decided that Stanza library allows to determine all named entity recognition really nice in Ukrainian languages, and the list of entities this list is really wide. It could be locations, persons, organizations, even amount of money, time, which can be included to the text, and we decided, and our results confirm that Stanza is a nice neural network model, even for propaganda, for emotion detecting in the text, but Stanza has little issues. But for determining named entity, Stanza is really nice, even for Ukrainian language. So we did the research with Spicy, but we decided that Stanza is like fully accessible for our texts, for our research. Thank you.
Thank you.
Thank you. Thank you. Another questions?
May I ask a question?
Yes.
Well, you mentioned about comparison of your automatic analysis with experts' opinions. It's very important, but the fact is that in such a field, experts may be very political biased and provide this information just in order to deceive the algorithms and to achieve their political goals. Did you investigate possible ways for recognizing such malicious influences and to counteract them?
Thank you so much for your question. It's really important topic in this field. I guess we can make some distinguish between comparison between our models results and results of the experts, and we can like distinguish these results and make some conclusions. For example, we can have text, and there would be appeal to fear, repetition, or many other techniques used in propaganda, and experts could say that here is only repetition and nothing at all. And I guess it would be a great approach to distinguish our results, amount of our results and amount of expert results, and maybe make some decisions based on these differences. It could be nice, I guess. Thank you.
Thank you.
Thank you very much. Is there any question? No? Thank you very much, and we continue.
Thank you.
The next it will be Vitaly Savchenko, and now it will be really a modeling of media influence on personal information security.
Good afternoon, ladies and gentlemen. Good afternoon, dear participants of the conference. I'm glad to see you all at this scientific event. Continuing the topic of information warfare and influence of propaganda, I would like to present the publication with topic Modeling of Media Influence on Personal Information Security. My name is Vitaly Savchenko, professor of the State University of Information and Communication Technologies. And we live in an information society full of various media. Radio and TV, newspapers, magazines, social networks, and services, they all bring us information, changing our thoughts and views. By perceiving the information from media over a long period of time, we can change our beliefs in accordance with the opinion of the majority. This feature of human psychology is called conformism. Knowing this, some media can use information to manipulate us, spread propaganda and fakes. The main problem, which has not been solved for a long time, is that we want to have access to information and be protected from disinformation and manipulation at the same time. So, how do we stay protected from malicious information and be informed at the same time? And how to measure the degree of information influence on human behavior? Our work explores a mathematical model of media influence on human behavior with hope to develop effective protection tools based on our model in the future. During the research, we examined various models of the influence of information on human behavior and determined the following. Existing mathematical models of human behavior under the influence of information have the following disadvantages. Statistical models are overloaded with internal psychological analysis of the personality, which is difficult to adapt to the influence of mass media. Models of personal protection in social networks consider a person as a stable recipient of information regardless of its relevance. Mathematical models of conformal human behavior are the most suitable, although they require improvement for the possibility of using media information in them. The purpose of our work is to develop and investigate the mathematical model that can provide a quantitative analysis of the relationship between media information and personal information security, allowing researchers to develop more effective strategies to promote individual security. The mathematical model of an individual's information security is based on the assumption that an individual has a priori beliefs before the media impact and a posteriori beliefs after the media impact. Also, an individual has their own degree of independence and level of trust in the media that influence them. At the same time, the media have initial values of influence on the individual, which collectively form an information portrait of the individual. Formula 3 describes the change of an individual's behavior under the influence of the media in matrix form. In order to ensure the information security of an individual, it's necessary that their posterior probability of a new state remains within certain limits relative to their priori probability, which is shown in Formula 4. Thus, as we have defined, the information security on an individual is the difference between the maximum and minimum values of a posterior probability. But how to achieve this state? Numerous media impact on us constantly and try to change our posteriori beliefs to their side. The only way way out of this situation for an individual is to independently change the media impact on themselves. To test our model, we applied scenario of a presidential election campaign with the one candidate X and two alternative media 1 and media 2. Media 1 supports candidate X with the level of 0.9. Media 2 supports the same candidate X with the level 0.1. Different individuals have their own opinion about the candidate X, which is expressed through their initial beliefs and their own degree of personal independence. A specific individual can switch the impact on themselves between media 1, media 2 in order to stay with their initial beliefs as long as possible. Imagine that we are dealing with a fairly independent individual with a degree of independence at the level 0.8. Figure 1 shows that the case when the individual is more inclined to the opinion of media 1 and then the initial beliefs are 0.8. In this case, any impact of media 2 leads to a change in the individual's beliefs to the opposite, but such influence can be compensated by 4 inclusions of media 1. So the resulting information security of the individual is 0.16. If the individual was inclined to alternative point of view, the situation would be exact opposite, as it's shown in figure 2. In this slide, you can see how an individual's information security depends on their degree of independence and priori beliefs. It can be seen that with increase of the degree of independence, the value of the difference between the maximum and minimum values of posteriori probability decrease almost linearly and reach zero when the values of the degree of independence is equal to 1. I want to remind you that the smaller the value of this difference, the greater the information security of the individual. At first glance, such a conclusion is trivial, but in this case, we have obtained numerical values of the dependence of information security on the degree of confidence of the individual. This approach is widely used by numerous psychological coaches and trainers. They suggest to increase your self-confidence, which means increasing your information security. The maximum value of the difference between posterior probabilities is 0.8, which is determined by the condition of our example. From the beginning of the experiment, we have established that media 1 supports the candidate at the level 0.9 and media 2 at the 0.1. The difference between two values is 0.8, which is the maximum value of the difference or is the worst case scenario for information security for a completely dependent individual. Thus, to stick to your beliefs, you will have to manipulate information between media 1 and media 2 manually. Therefore, the interesting question is how often should information sources be changed and to ensure information security? And what type of strategy should be used? Should we always receive information from the same media? As can be seen from the table 1, at low level values of the degree of independence, the change of media is carried out in equal proportion between media 1 and media 2. When the degree of the independence of an individual increases in order to minimize the change in the posterior probability, the individual should more often choose the media that is closer to their beliefs. Otherwise, the minimum difference of the posteriori probability is not ensured. In the case when the individual doesn't have clear a priori beliefs, the change of media is carried out proportionally 10 to 10. The concluded research makes it possible to draw some following conclusions. First, if you want to achieve our own information security, we need to assess how the media will impact on our behavior. But first of all, it's necessary to have such value of the degree of independence that would provide the resulting value of the posterior probability within the given limits relative to our initial beliefs. The information security model that we have developed and investigated in the work is based on probabilistic control of the behavior of an individual under the influence of the media. This allows us to explore different scenarios of managing information impact on the media on a person and select the appropriate technology of managing information flows to ensure the required level of their information security. Simulation of various scenarios of media flow management confirms the adequacy of applied model and indicates that a person with a high level of independence and well thought out media change technology is able to resist most information influence and thereby ensure their own information security at a given level. Above all, we see significant prospects of the implementation of such a model. Imagine that tomorrow you will have the mobile application on your smartphone, which you can configure to ensure your information personal security. This application will analyze the content of messages and automatically filter them depending on your condition, ability to counteract negative impact, and your beliefs. This will save you a significant number of nerve cells and vital energy for healthy and happy life. Dear participants of the conference, thank you for your attention.
Thank you very much. So, dear colleagues, please, questions? So, please. Nicole.
Thank you for your presentation. It's very informative. Just I likely missed one moment. What languages you operate in your system?
If you talk about our ordinary languages, Ukrainian, English, and so on, we don't use languages at all. We examine only the influence of the media, positive or negative. You support this idea that media translate to you or don't support. We operate with basic, quite simple terms in this model because the model is very basic. It gives us the opportunity to understand how the media influence on the person. And we try to explore this model on ourselves. It's quite interesting to get the result that it really works because you can change the media influence by manipulating the channels of the media. So we don't use languages. No, sorry.
Okay, I understand.
Thank
Is there any other question, colleagues? No? Thank you very much, and
Thank
we
you.
go on. Thank you. The next it will be Gleb Gorban. Distributed file replacement registrations on computer network.
Microphone.
Yes, yeah, microphone. We don't hear you.
You're muted.
Please, Gleb Gorban, we don't hear you. Maybe your mic is muted. Microphone.
I'm sorry. Yes.
Mhm.
Good afternoon, dear participants of conference. My name is Philip Holborn, and I'm an associate professor of the Department of Software Engineering in the Black Sea National University, named by Petro Mogila from Nikolaev city of Ukraine. And I would like to present a report by the following topic. Can you see the presentation now?
Yes.
Yes, the development of information and communication technologies has led to the proliferation of distributed data processing systems based on computer networks. There are scientific and technical tasks of processing ultra-large data sets, the realization of which is not enough for a single computer with a single processor architecture. Today, real computer networks are characterized by disadvantages, especially distributed networks with is a very heterogeneous medium of information transmission. The actual speed of information transfer directly depends on the bandwidth of the slowest network. Thus, a remote user's access to a corporate database can be significantly hampered. On the other hand, does a remote user always need absolute access to the entire information base? In many cases, only information that is directly related to the business environment is requested. There is a need to choose a numerical optimality criterion that determines the average time of user request execution and is convenient for optimal file placement. The choice of such a characteristic of the mass service systems is due to the fact that users are usually interested not in minimizing the size of the query and any other characteristics of the mass service system, but in ensuring that the requests are processed in a little time as possible. When determining the average waiting time for request value in the service query, it is recommended to use the following formula, where rho is the load factor of the service device and can be from 0 to 1, and lambda is the intensity of the request flow, the average number of packets claiming to be transmitted per unit of time. And when distributing requests among the service devices, they must minimize the value of W while the route of the request is unknown in advance, etc. The request can be processed by the service device or by several service devices sequentially. The target function is selected as a combination of traffic parameters through communication channels is the network where C is the weighting factors that take into account the average packet service time of the communication channel, and the problem of creating switching systems designed to analyze the state of the network at any given time and optimize data transpirations has not been resolved, and systems that perform relatively simple optimization of the distribution of data transmission over network channels remain extremely expensive, and the efficacy of using the capabilities of the
Oh, I'm sorry.
universal.
We
Yes,
see only page introduction. Maybe
yes,
is it normal? We
yes,
see on your presentation. We see only
yes. Let's
your page
analyze. Yes,
introduction. It's okay. Yes.
I try to quick. Let's analyze the network as multi device mass service systems as a system where several identical service devices process one request query. The request at the very beginning of the query is sent to one of the free devices for service, and the request at the multi-device query shown in this slide and differs from the last slide, which shows general yes. Ну, давайте так, зараз п'ятий слайд показується, так? Let's analyze.
In English, please.
Let's analyze the network as a multi-device mass service systems as a system where several identical service devices process one request query. The request at the very beginning of the query is sent to one of the free devices for services. And the next slide, we can see some differs from the query coordination, which shows several single device queries operating in parallel. And if in all cases the service devices and the incoming flow of requests are identical, and in a single device requests arrive randomly, and once in the query remain there, then it turns out that the operation of a multi-device query is preferable to single device queries operation in parallel. And when designing a querying system, the goal is to ensure that its utilization at constant loads is 60-70%. The exact method for determining the equipment utilization rate is a mass service system with one service device is given by the following expressions, where E from N is the average number of requests received per unit of service time, and E from T S is the average time for servicing the first request. And suppose there are M service devices in the same type, so it sends a request to any device per unit of time, request per unit of time. And consequently, the utilization rate of a particular device can be calculated by the following formula, when the ratio rho should be less than 1, and let W be the number of requests waiting to be served at a certain time, and the Q be the number of system requests waiting and being served at that time. And let's go on T. W's is the service waiting time, and TQs is the time a request takes is the system, and the time it spends both waiting or and being served. Now the following formulas demonstrate how to calculate the probability that all services are busy at given time, and the equation reduces to B rho when M equals to 1. And several works have been devoted to solving the problem of rational placement of information files on local network nodes, which differ in both the problem statement and the method of its solution. We study a network with a single path topology and local area networks with a bus topology characterized by a relative ease of management, low arbitration time, ease of expansion, and fairly high reliability. As an aspect of rationality, a single time required to service requests received by the system within a unit of time is accepted. And the time it takes to send data from the node car data during the execution of CAS type search query to the file F is equal to the following formula, and then the only time required to send data through communication channels between nodes when executing search queries received by the system during a unit of time is set as the following formula. And noting F null as the goal function, we obtain the exact model of the problem of optimal distribution of copies of files between network nodes in terms of the minimum uniform time required to service all requests received in the system within a unit of time, associated with the time of discrete programming problems with Boolean variables, and we try to minimize the function f when the value of L is in the following formulas is the file size of file f is. And this slide demonstrates some formulas which can calculate some values to minimize the goal function f zeros when lambda k I and j is the intensity of k-type search request to the file f is from the node chi yots t is the processing time of a k-type search request to the file f is in the node k use. And now I want to demonstrate the algorithmic implementation of the model, which consists of the main algorithm. When at the beginning we select of the optimization criteria and form the matrix C and do the initial file distributions, and we calculate the matrix X. Each element of it must be equal one or no. The element of matrix X equals 1 when the element of matrix C less than 0, and it must be equals 0 when the element of matrix C more or equal 0. And the second stage of algorithm is the redistribution of files. We create a vector of values E, where epsilon yod equals to 0 or 1. And during the algorithm, after redistributing files from a certain field node k yields, the corresponding component epsilon use of the vector here is set to this node is closed for redistribution. And this the following slide demonstrates how we minimize the values of matrix C. And the next slide demonstrates this step of the algorithm, which calculates the values of matrix C and calculates the values of matrix 1. And as an aspect of optimality, the average amount of information set over the communication lines when processing request is taken, and the resulting matrix of the experience distributions of files to network nodes as a result of the calculation using the optimization program is as follows. And for example, files that have been modified are often stored in one copy each, and copies of the files are duplicated in the local databases of network nodes. And if we take a single time as an optimality aspect, the time required to service all requests that come into the system within 1 hour, the matrix of the appropriate file allocation is of a different type, which is presented in this slide. And to determine the intensity of access to various files of the transformation base, we use the resident program which called query analyzer writer in the assemble programming language, and the language guarantees the compactness and flexibility when writing resident programs and does not allow errors in the measured processes. The resident program is loaded on all network nodes, and the computer time is synchronized. And the conclusion, the method of optimization of distributed file placement registration in the computer network based on the waiting time and the problem of creating switching systems designed to analyze the state of the network at any given time to and optimal data transpiration to find optimal solution. A practical implementation of the method of balancing the load of the database management system network nodes intended for processing large and ultra-large volumes of databases is proposed. The results of the operation of the revenue accounting system based on the proposed method indicate of possibility of a significant increase in the speed of data processing in large volume databases by using mechanism for optimizing the load of network nodes to process databases. The application of the method allows to increase the productivity and reduce the reaction time for the information system working with the database management systems. Thank you for your attention.
Thank you very much. Questions, please?
May I start?
Yes.
Okay, so thank you for the presentation. It's rather like practical oriented. So the question is, have you measured the results? What are the optimization like percentage? Which indicators have you measured? And can you share these practical results, please?
We plan to discover to research some other optimization criteria of distribution files in the network nodes, but now it haven't researched yet, but it is planned to research it in the future. Thank you for your questions.
Okay.
Thank you. Another questions? No questions. Okay. So we go on. The next report called a method of assessing investment risks based on fuzzy modeling on the net present value of innovative projects. Innovative projects, excuse me. Bogdan Zhuravell?
Yes, I'm here.
Yes, please.
So
Uh,
I need the.
so, yes. Okay.
I might having a problem with my internet connection, so I'm gonna apologize in advance. All right. I represent the University of York in England, and it is a pleasure for me to speak at this conference today, albeit remotely. And having graduated from the Faculty of Information Technology, I would like to take this opportunity to express my gratitude to the teaching staff and especially to the Dean, Vitaly Snityuk, for the knowledge I gained during my studies and advices which helped me to choose my next path. And today I would like to share the results of our research, which is the method of assessing investment risks based on the fuzzy modeling of the net presented value of innovative projects. So shall I begin? The last few decades have clearly demonstrated the scientific and practical significance of innovation-driven development as a crucial factor in the economic growth of national economies and all economic entities. A distinctive feature of innovation project design is the predictive nature of its outcomes. In investment analysis, the most frequently used predictive model for evaluating the efficiency of innovation projects is the net presented value, or NPV, of the project. This metric reflects the profit that an investor expects to receive from implementing the project. The net presented value is calculated using this formula, and the net presented value itself characterizes the overall economic effects of the innovative project and serve as a tool to evaluate the feasibility of investment financial resources. If NPV is greater than 0, then there is a full payback on the investment, and the NPV values indicates the investor profit. If NPV is less than 0, the investment does not pay off, resulting in a loss for the investor. And one of the critical parameters of the efficiency indicator for innovative projects is the expected cash flow for a given year. Since this parameter is predictive in the nature, so its accuracy diminishes as the forecast horizon extends further into the future. To increase the reliability of this parameter, the expected cash flow is represented using the fuzzy linguistic evaluations. So what is the fuzzy linguistic evaluation? The fuzzy linguistic assessment is a numerical evaluation expressed in the statements with qualifiers like approximately or about. For example, the cash inflow is approximately equal to C, or we could describe the interval. The cash inflow is approximately in the interval from C to D. So such evaluations can be approximated by the fuzzy LR type numbers, and triangular numbers like this one are assessments of the first kind, and trapezoidal numbers of this form are assessed of the second kind. Since these values C and D in these numbers are defined by linguistic evaluations, the tasks of constructing such numbers reduce the determining the fuzzy coefficients alpha and beta, which define the interval boundaries of possible cash flow values. How to calculate these fuzzy coefficients? The fuzzy coefficients define the boundaries of the support of the fuzzy set A, that is the points where the membership function mu A is equal to 0.01. In practice, the most commonly used method for representing the fuzzy LR numbers involves standard Gaussian and combined Gaussian membership functions, represented on this figure. And the standard Gaussian function is used to define the fuzzy set A, which is the number approximately equal to C and could be described by this formula, which is the standard Gaussian, where A equal to this and B is the distance between the transition points of this function. The Gaussian function has an unlimited support range because it's asymptotically approach 0 on both sides. However, for practical purposes, the support of this function can be considered bounded at the points where its value is approximately 0.01, corresponding to the complete non-membership of an element in the fuzzy set A. Therefore, the coefficients alpha and beta can be obtained from this equation, which is basically 0.01. So we talk about just about the Gaussian function. Now I'm talking about the combined Gaussian function. The combined Gaussian function is used to define the fuzzy set A the number approximately lies in the interval from C to D, and which is described by this form, where mu b is the membership function of the fuzzy set B, the number is around C, and the mu c is the membership function of the fuzzy set C, the number is around B. In this case, the fuzzy coefficients alpha and beta can be found from the same equations as the previous, but in this case for both. Thus, deconstructing the fuzzy LR numbers reduces to calculating the distance between transition points of the corresponding Gaussian function. So, and let's talk about the calculation of the distance between the transition points. The basis for calculating this distance is experimental data, which according to experts reflects the transition points for numbers approximately equal to a certain value, and the results are provided in this table. For the numbers listed in this column, the distance between transition points is calculating using the corresponding formulas in the second column. Each row represents to each row. For other two digits numbers, the distance is calculating using this formula provided in this table. If it's necessary to find the distance between transition points for number less than 99, so we obviously use this table. But in otherwise, we use this algorithm, which is quite intense. And as a result, the value of function b with parameter n will be obtained. After this, the coefficients alpha and beta determine the range of possible cash inflow values in each year. So right now we're moving a little bit to more practical part, to modeling the random scenarios and risk assessment. And random scenario modeling will be conducted using the Neyman rejection method. The following principles underline this method. Let the random variable capital X be defined on the interval a to b and has a bounded density function f from above. Also, let R1 and R2 be independent realizations of the base random variable xi, and x equal to this and while y equal to this, where m is just the upper bound of the function f. Then, if this condition holds, then the value x is realization of the random variable capital X. Depending on the type of the fuzzy linguistic evaluation of the expected cash inflow, either the standard or combined Gaussian membership functions is used as the probability density function. Given this, the NPV indicator models as follows. For each ETH year, for each realization of X of random variable capital X, on the interval of its possible values alpha I and beta I, the value this is calculated, where the cash flow I is equal to small x. Then NPV equal to this sum, an indicator can be obtained. The probability can be defined as a ratio of the negative scenarios to its total number, where k number of negative values of NPV and m number of conducted experiments. So we conduct the experiment to assess the investment risk of a certain 3-year innovative project with the initial investment amount of 265 units and interest rate of 5%. And the table provides estimates of the expert profit for each year. Based on this data, for the random variable capital X, which is equal to cash flow, the following interval were obtained for each year using the after-mentioned mathematical framework. Simulation of the net presented value within these intervals over 1,000 model runs indicate that the investment risks is 0.065, which is considered moderate. An approach to assessing investment risks based on the fuzzy modeling of the efficiency of an innovative project has been considered. The following model of efficiency is represented by the net presented value indicator, where the cash flow parameter is defined using fuzzy linguistic numbers. A procedure for approximating linguistic evaluations with the fuzzy numbers based on the Gaussian membership function has been proposed. To simulate the NPV indicator, the Neyman rejection method is applied, with the Gaussian functions serving as the probability density functions for the expected cash flow distribution. The conducted experiment demonstrated the practical feasibility of the approach along with its simplicity and versatility. Thank you.
Thank you very much. Questions, please.
I have one question regarding the tuning of this model. So the quarterly reports earnings reports are published quarterly, and there is an option to tune the model. Did you consider this option? And another question, since you are using random variables for a complex model, did you consider Monte Carlo simulation? Thank you.
Sorry, would you mind to repeat the question again? You mean how to use another approach except the Monte Carlo simulation?
Did you use Monte Carlo simulation for
Exactly,
your...
it is the Monte Carlo simulation.
Okay, I got it. And did you try to account for quarterly earnings releases?
No, we didn't count for the quarterly releases. We just did for each year.
Okay, thank you.
Thank you very much. Another questions, please. No questions. Thank you very much. So we go on. The next is Chernenky, Alexander. Toward the information technology for online citizen services, detection and assessment on e-government national portals.
Yes, okay. Do you see my presentation?
Yes, sir, we see.
Yes, так, one more. Okay. Good day, dear colleagues. My name is Chernenko Alexander. Today I will present common work with Andrei Kop towards information technology for online citizen services, detection and assessment on e-government national portals. As the title of the study indicates, we will talk about a study of national government portals. And the main purpose of the study is to improve the assessment of the structure and content of these portals in terms of availability and variety of services provided to citizens. The analysis is aimed at identifying the key characteristics of the web portals, such as the number of available electronic services, their thematic distribution by a government service catalog, as well as the level of richness of services in various citizen service branches. The report consists of 7 parts, which briefly outline the essence of our work. About our motivation. Today, humanity lives in the period of the information age, the determinant of the evolution of which is the rapid development of new information and communication technologies that have been developing since the second half of the 20th century. Digital technology and new opportunities that it brings were swiftly adopted by world society, which in turn caused the beginning of the transformation of various aspects of human life, including politics, sure. In the late 20th century and beginning on 21st century, new technologies significantly influenced the course of foreign and domestic policy of different countries. Information and communication technologies have begun to change the attitudes of states, governments, politicians on economy, on methods of governance, and most importantly, on improving the communicate ways with their citizens. There was an understanding that post-industrial society is a society that cannot do without the dominance of modern technologies. And in this way, it is possible to consider the concept of a post-industrial society to be equivalent to an informational society. As the internet began to spread widely around the world, quite a lot of enthusiasts interested in improving communication with government agencies began to use the new technology to create the first relevant web resource, which in turn could be supported by local governments. With the following evolution of internet-related technologies, at the beginning of the 21st century emerged understanding that a part of the development of an inclusive information society, it is necessary to reboot old methods of public administration and develop e-government models. In turn, the e-government model is open for communication with citizens and includes the development and support of specialized government web portals and online services through which citizens can receive information and services with the help of the internet. Political science today has a rather large arsenal of research methods. However, like all other sciences, social sciences and political science in particular, are in state of constant movement, transformation, and improvement of methodology. In terms of significant transformations, there has recently been a growing interest among humanities researchers in computational research methods using digital technology. In this case, it can be spotted the emergence of interdisciplinary field, namely computational social science, or CSS. The growing interest of scholars in computational social science can also be justified by the rapid development of the internet and the growth of digital data worldwide. Today, there are several areas of using computer technology and political science. The internet evolution has been one of many reasons for the widespread digitalization of human life. Today, any user activity on the internet can be recorded, and at the same time, web pages, social networks, online media, blogs, file exchange, etc., can be a source of valuable information for researchers. In general, the creation of government web portals is part of the e-government model. The web scraping approach is valuable for political science because it allows us to examine how websites are used. In our work, we use data from the e-Government Development Index, or EGDI database, which was taken in Excel format. Addresses of government's web portals were taken from the dedicated sections of EGDA. The process starts with converting data from Excel-based spreadsheet format to JSON format for further processing and storage using Python programming language. The pandas library is used, which allows to load data from an Excel file. The required data set is contained in the special file e-gov-data-2024 XLSX. The data preparation process could be formally described as the set operations that ensure the transformation of the Excel spreadsheet into the JSON format file. XLSX, the spreadsheet represented as a set of records. DDF, the data frame. TJSON, the function used to transform the data frame into JSON, a set of object DJSON. The dict, the Python dictionary to which DJSON is deserialized. WJSON, the writing operations to JSON file FJSON. The picture on the slide visually demonstrates the use of developed eGov prepared JSON PI, Python component for the transformation of Excel spreadsheet data into JSON file using JSON library. Then the obtained JSON file is used by another software component that analyzes national portals using web scraping techniques. Using obtained data stored as the JSON document eGov data 2024 JSON, each country's national web portal is accessed by making hypertransfer protocol requests. All hyperlinks are extracted from the resulting HTML content, which is then analyzed for thematic keywords for relevant to major government service areas and citizen services, according to integrated architecture framework for e-government. For example, services for taxation. Keywords is tax, finance, income, money, debt, credit. For education, education, school study, child training, student, and etc. The example of United Kingdom national portals data scraping is demonstrated on slide. As can be seen, for any country, a thematic structure of citizen services is built based on the collected hyperlinks. The general process of processing data from national e-government portals can be formally presented as follows, as shown on the slide. LE, the set of hyperlinks extracted from the web portal page. PE, the set of thematic categories and hyperlinks that we assume provide the access to corresponding citizen services. SE, the set of detected citizen services based on the introduced thematic categories and keywords. SRE, the service richness of the national portal with the government services. Further analysis of the data obtained using the introduced pipelines requires powerful visual tools, freely accessible and easy to use for non-professional in informational technology. For example, social or political scientists. Hence, we propose use Microsoft Power BI for the further analysis of the obtained web scraping results. Picture on the slide visually demonstrates the use of development eGovPers websites, Python component, and Power BI data analytics tools for the national web portal scraping and evaluation. The general EGDI-based datasets includes 193 countries. Each has the government evaluation and the URL of national portal. However, a lot of national portals mentioned on the EGDI website are either not accessible or do not provide English version. Moreover, the proposed toolkit has failed to process several web portals among the remains on. Table on the slide demonstrates the states of EGDI dataset discovery, preliminary check, and the processing using the proposed technology. As can be seen from table, almost 55% of country records were removed from the initial datasets because of the inaccessible national portals or absence of English versions. The remains 87 records were processed using the proposed solution. However, only 79% of available national portals were successfully scraped. Country national portals are placed on the scatter chart. X-axis of the scatter chart is online service indexes, or OSI, which estimates the scope and quality of online services provided by a web portal according to EGDI methodology. Y-axis is service richness, which estimates the correspondence of national portal to integrated architecture framework for e-government. On the slide, we consider the first 10 countries ordered by online service indexes values. Estonia, Ukraine, Singapore, United Kingdom, Japan, Kazakhstan, China, Germany, Australia, and Netherlands. And it's interesting that processing of Ukraine, Australia, and Netherlands national portals has resulted into 0 citizen services detected, and therefore 0.0 values for the service richness measures. However, according to the online service indexes measurement on the EGDI website, Ukraine has 0.99 score, while Australia and Netherlands have 0.92. The analysis of Ukrainian indicators resulted into the fact that EGDI rating contains the URL of the cabinet minister homepage instead of the DIA portal. Whereas DIA portal provides the online citizen services searched by the proposed technology according to integrated architecture framework for e-government. As for the Australian and Dutch national portals, the reasons for undetectable online services are similar. This research proposed that the informational technology for online citizen services detection and assessment on e-government national portals. The main purpose of this study was to improve the assessment of the structure and content of national portals in terms of availability and the variety of online services provided to citizens. Such a solution can be used by political scientists to perform experiments, find the best practices for online citizen services provision, compare different national portals, and get valuable insights. In future, the proposed approach will be improved to traverse all national portals page. Thank you for your attention.
Thank you very much. Dear colleagues, please, questions? Yes, Pablo?
Thank you very much for your very engaging presentation. I would like to ask, how does the system may handle language diversity and localization issues when detecting and assessing services on portals serving multilingual populations, taking into account that you showed us that the system probably can be applied to various cities with various languages and various cultures. Thank you very much in advance.
I'm sorry, can you repeat, please, question? Because I have a problem with sound. Can you repeat it and not so faster?
How does the system can or may handle language diversity and localization issues when detecting and assessing services on portals serving multilingual populations?
It's
Did you
hard.
think about language diversity
I can
and
answer.
different localization issues at all?
I can answer as the second co-author, responsible mostly for this technical process. Now we address only websites that are presented in English or have English versions for these citizen portals, and mostly of them indeed are those. And in the slide where we demonstrated filtering, we had the first step with the manual selection, or better to say manual retraction of those websites that unfortunately are not in English and don't have English versions. And now it's the major limitation of the proposed technique. However, it's planned to use some extra tools, third-party tools for translation of those data extracted from sites that don't support English versions or English texts.
Okay, got it. Fully understood. Thank you very much.
Thank you.
So, another questions? No questions. Thank you very much. And the last report in our plenary section is Evgeny Udovichenko is here.
Yeah. Hello,
Yes.
dear colleagues.
Evgeny Udovichenko, key technologies and approaches to attaching beginners in the international service IT company SoftServe.
Yeah,
Okay.
thank you. For me, it's a great pleasure to present our approaches, and now I'll share my screen. Yeah, I hope you see it. So today we are gonna talk about the way our company deal with young talents, with students. But first of all, I'd like to tell you a couple of facts about our company. Software is a global company which has 31 years of experience. We have more than 20,000 of projects in our portfolio. Now there are more than 10,000 of employees working in 62 offices in 16 countries all around the world. But as you see, it's North America, South America, Europe, Asia, but most of the development offices are located in Europe, especially in Ukraine. Most of those employees, especially engineering specialties, are located in Ukraine. So what are our clients and what projects we are working on? Now we are working on more than 1,400 projects. It's startups, ISVs, and finally it's large corporations and Fortune 500 companies. As you may see, they are from different areas, starting from networking and finishing banking sector, energy, healthcare, and so on and so on. What are main technologies and directions of our projects? Of course, we focus on modern technologies, mostly web, mobile, but also we work in the field of UI, UX design because we propose development of the idea of our clients from scratch to the full realization. And that's what UX design office is working on. Also, we have a huge R&D department working in big data, AI and ML, robotics, and other directions. Maybe it's one of the biggest R&D departments in country. Also, our robotics department works on different projects related even to the space programs together with NASA. In such difficult times, we see our goal in supporting our country. So our charity fund Open Eyes collected more than $23 million and gave it to our forces, to our country. More than 800 volunteers are working on our social projects, on our volunteer initiatives, and we collect you can say ambulances and a lot of humanitarian aid which is given to our country and forces. And also we have such thing like corporate crowdsourcing platform which is called OpenTech, and it allows our specialists, our professionals to donate their time and skills to make our world and our country better. How do they do it? They take part in our pro bono projects, which we make for different public organizations, state and educational institutes in different areas such as healthcare, diversity, equity, and inclusion decisions, improving educational opportunities, and so on, so on, so on. Why do we support IT education and how do we deal with the young talents? First of all, as I've already mentioned, most of our engineering offices, our engineering departments are located in Ukraine. And so we see our mission in development of other students together with universities to make great tech leaders, tech specialists who can compete in the global world, because we see that those young specialists will become maybe in future our employees, and we want them to be competitive on the global market. So what are the ways of our interaction with such young talents, with the students, and with universities? Of course, universities is the main source of such specialists, the place where students study, and with these universities we cooperate. We have 62 partner universities, and every year more than 16,000 students participate in different activities, events, initiatives from SoftSec. What are key products in our cooperation with universities and with students? First of all, it's dual study. It's our benefit program, which allows students that are our employees to combine studying and work in our company. We can sign an agreement between university, student, and our company, and it allows to combine studying and work in more easy way. Second is R&D incubator. The name talks about itself. It's initiative that allows students to try themselves in different R&D initiatives. Mostly it's big data and data analysis initiatives, but we plan also other R&D directions to be started soon. Also, we provide such initiative like Leadership Week. It's our solution to develop future leaders, where our specialists share their knowledge in management, in teamwork, in different soft skills in order to strengthen their soft skills and their leadership skills. Also, we take part in job fairs. It's a great opportunity for us to present the possibilities that company offers to young specialists. Also, we provide hackathons from our company, and it's also a great way to get to know about young talents, especially the winners, and we often have job opportunities for them. And also we support hackathons held by our partners. It's university, different students organization, and so on. We help with prizes, with jury, and with tasks. Also, when there is need in some technology in company, we can provide winter summer school. It's also a great opportunity for the company to gather people interested in some technology, give them knowledge, and it is also a great source in the future for us for some specific technologies. Also, there is a possibility for students of our partner university to have practice in software. It's like working on their own project, and we can sign an agreement and sign all the needed documents, and students can on the working on their own project get the practice in our company with the help of our mentors, of course. Also, there are internships in our company. It's working in our non-commercial projects, and it's also a great possibility for the students to gain their first experience, and for us it's also the great source of our future employees, because for us taking person from internship to the commercial project, it's like changing the project of this person. It's already ready for the work on it. Also, we have ambassadors program. What it is, it's a program which allows us to form students community among different universities, and we support their initiatives, support their events, support their spaces, and so on. And of course, there are two other initiatives like Software Academy and University Joint programs. And about them, I'd like to tell more detailed. First of all, Software Academy, it's the way that we can give knowledge to all persons, including students, that want to join IT. It's divided to 3 steps, which suits to different level of knowledge. First of all, it's the fundamentals level. Our solutions from this level gives the knowledge of core, gives the core knowledge of some specific programming language or some specific technology, and it gives mostly theoretical, but a little of practical knowledge. Next is the practical course, when a person already has some theoretical knowledge, knows the basis of some technology. It's time to convert the knowledge to practical skill and to apply their knowledge to doing some practical tasks. And after that, the person is ready to join our project study, to join some team, interacting with other team, working on their real project. And after that, the person becomes job ready, and everybody's happy. The person is ready to get the first offer, and we are happy because the person is ready to join our commercial projects. Next form of our interaction with the university is joint programs. It's a huge complex solution which we started in several universities, in 7 universities, including Kyiv National University. And its solution that is provided with served together with the university. What it is? It's a solution where we make the studying process more quality. In which way? First of all, we update the program. We involve our specialists to the studying process, specialists from software, especially engineering specialists. Also, we update the program. We make the review of these programs. And also, we provide some extra modules. What are these modules? On the first course, there are several modules. First of all, it's Intro to IT. The game is to the main purpose is to open the world of IT to the students of the first course. Our specialists share the experience from the fields where they work. In the second course, it's a Tech Boost. It's like powerful technical courses on different programming language. And on the second course, it's our solution called IT Projects Garage. It's a possibility for students to apply their knowledge and practical at the practice. Apply the knowledge on the practice, working together in groups, in team, on their own project, with help of our mentors, of course. And some numbers. We have 7 university partners in this program. 85% of the students implement their first project, from idea to the launch on our on second course. Last year, more than 900 students joined this program in all of these universities, and more than 100 of our mentors are involved and contribute to this program, like mentoring teams, holding webinars, workshops, and taking part in other activities. So that's the way how we work with young talents. Here are our social networks links, and thank you for your attention.
Thank you very much. Dear colleagues, is there any questions?
Alexander Alexandrovich, may I say a few words?
I give you the floor.
I want to thank dear Evgeny and SoftServe company for your gifts for participants our conference. And I have a few words about our joint project with that. I load presentation, little presentation, small presentation. Dear colleagues, I would like to say a few words about our joint project. Project Open Education Resource with Ukraine. The project Open Education Resource with Ukraine and Open Educational Resource with Ukraine Informatics, founded by the German Academic Exchange Service, in Deutsch DAT, aims to support Ukrainian partner universities of Leibniz University, Hanover in Kyiv, Dnipro, Kharkiv, and Lviv in times of crisis in times of war, and assist them in maintaining further development in digitalizing teaching courses in the subject areas of biomedical engineering, biology, material science, computer science, and information technology. This course, 1 minute. These courses are being produced under Creative Commons licenses and anchored in the ongoing technical activities on the respective partner university. They are subtitled in English and Ukrainian and published on TIV portal, the German National Portal for Scientific Videos of the Libraries Information Center for Sciences and Technology and University Library. The teaching learning videos receive a DOI, are permanently stored and provided with semantic data and standardized metadata, which flow into OR search index via open interfaces. Thus, they are accessible, citable, easy to find, and free to use. In such a way, the project contributes to the internationalization, digitalization, and openness of education and gives the teachers and students new possibilities. More details you can see on link above the slide. Next slide, you can see our online course, Natural Language Processing, author Tmenova Natalia Pilipina, PhD Associate Professor at our Faculty of Information Technology. Second author is Alexander Alexandrovich Marchenko, as I know. Maybe it is not true, but I don't know all. Dear colleagues, I invite you to join this project. All links you can see on my presentation. Thank you for your attention. Thank you, Alexander Alexandrovich. It's all.
Thank you very much. So our program is complete. So our session is finished. Thank you very much. It was a pleasure and honor to work with you, dear colleagues. So thank you very much and goodbye.
Bye. To next session.
Goodbye.
To next session. See you next session.
See you later.